In this video, we're going to be talking about greatest common factors. So we're going to start off with just some numbers. So this is kind of the middle school version of factoring greatest common factors, and then we'll get a little more advanced. So if we're asked what is the GCF, or the greatest common factor of 18 and 24, we need to consider all of the factors of each of those numbers. And so it may help to make a list of all of the factors of 18 and all of the factors of 24. So if we think through factors of 18, we know that 1 is a factor of any number, 2 is a factor of 18, and so is 3. I personally like to list mine out in pairs just so I can keep track of them a little more easily. So I know that 1 and 18 are factors, 2 and 9, 3 and 6. 4, is 4 a factor of 18? No. Is 5 a factor of 18? No. And then I already have 6. So this lets me know I've got all of my factors of 18. And then let's do the same for 24. So let's start with 1 and 24. 2 is a factor, 2 and 12. 3, is 3 a factor of 24? Yeah, 3 and 8. Is 4 a factor? Yeah, 4 and 6. Is 5 a factor of 24? No. But I do already have 6 here in my list, so I know I've got all of them. So once you've listed out all the factors, then you're considering what's the greatest number that's in both of those lists. What is the greatest factor that they have in common? And so starting with our biggest numbers, well, 18 and 24, those are not in common, 9 and 12, but 6 is in both of our lists. That is the greatest common factor. Notice that 3 is also a common factor of both of these numbers, and so is 2, but it's not the greatest common factor. So the GCF of 18 and 24 is 6. So this you probably first learned sometime in middle school. But what if you now have some variables? So what if it's not just numbers? What if you want to find the GCF of 18x squared and 24x? So same idea, let's start by listing out some factors, and let's start with just the numbers, just 18 and 24. And so those were the numbers that we just listed out a moment ago. But now we have to consider these variables. So x squared, that means x times x, right? So in addition to all these numbers being factors of 18x squared, some additional factors are an x and an x, right? This is x times x, or x squared. These are also factors of this term. For 24, well, we've got our factors of the number 24, and then also another x. That is a factor of this term, 24x. And so then we're looking for what is the greatest common factor. So looking at just the numbers, the greatest common factor is still 6. And then if we're looking at the variables, well, in both lists, we have at least one x, right? And so our greatest common factor of these two terms, or our GCF, is 6x. So notice that it's this x here, this is the minimum of what each of these factors need to have, right? This one did have an x times x, but they at least both had one x being multiplied, and so that is part of our GCF over here. Okay, we're going to take a break from GCF for a second, but then we'll tie it all back together. But let's consider a problem that just asks you to distribute. So this is something you've probably been doing for a while. So distribute means to multiply whatever is outside the parentheses by everything inside the parentheses. And so often teachers will draw arrows like this. So 5x times x squared. Well, 5 times the coefficient of 1 is 5. X times x squared, well, remember x squared is x times x, so we've got x times x times x, so x to the third power. Then we'll multiply 5x times 9x. 5 times 9 is 45, and x times x is x to the second power. And then distribute to the last term in the parentheses. 5x times a negative 3, or minus 3, would be negative 15x. So that's a reminder about what it means to distribute. So what if, instead of asking you to distribute something, what if I asked you to undistribute? So what if we know that a 4x goes here outside the parentheses, and we know what all this equals, but we need to figure out what goes inside of these parentheses here. We need to undistribute the 4x from this polynomial. And so we've got to think about, well, 4x multiplied by what number would equal 8x to the third power? So I know that 4 times 2 is 8, right? So there's going to be a 2 here. And then let's consider the variables. We've got to think about x times what would be x to the third power. And we could even look back up here, right? X times x to the second power is how we get x to the third. So this is a 2x to the second power, right? If we multiplied these together, we would get 8x to the third power. Then let's undistribute the 4x from this middle term, from the 4x squared. So 4 times 1 is 4, right? And I could put a plus 1 here, but I don't actually need to write the 1 since I'm going to have a variable I write. And so then I need to think about x times what is x to the second power. And that would be an x, right? So I could write that as 1x or just x. And then the third term, 4x times what is 12x. So 4 times 3 is 12. And notice that we don't need a variable here, right? 4x times 3 is 12x. And so we are finished here. So that's what it means to undistribute. And so what we actually just did, if we look at this polynomial here, the greatest common factor of these 3 terms is 4x. So what we did is we actually factored out the greatest common factor. This 4x was the GCF of these 3 terms. And then we thought of that as undistributing to figure out what was still in the parentheses here. All right, so instead of calling it undistributing now, what if we just call it factoring out the GCF? That is what we're doing. And so looking at this polynomial here, we need to consider the factors of all 3 terms and figure out which number and variable are the greatest common factor. So factors of 6, 18, and 15, let's consider those. It may help to start with a number with fewer factors, right? We've got to figure out factors they have in common. So let's start with a number that doesn't have as many factors. So maybe the 6, right? Factors of 6, we've got 1 and 6. Well, 1's a factor of everything. 6 is a factor of 18, but not of 15, right? So 6 can't be our GCF. Other factors of 6, 2. Well, 2 doesn't go into 15, but 3 goes into all of these numbers here, right? So our GCF, or our greatest common factor, is going to be a 3. And then let's consider if it also needs a variable with it. So is there a variable that we could factor out of all 3 terms? Do they all have a variable in common? And the answer would be no, right? This one does not have an x with it. And so our GCF of these 3 terms would be just the number 3. So now this is where we think of undistributing. We've got to figure out what goes in the parentheses so that if we distributed a 3 back into it, it would equal this. So 3 times what is 6x squared? And that would be 2x squared. 3 times what number is negative 18x? So it's going to need to be a negative, and that would be a negative 6x, right? If we multiply those, we'd get negative 18x. And then 3 times what is negative 15, and that would be negative 5. So this is what it means to factor out the greatest common factor. All right, we're going to look at just one more. And the directions on this one are a little bit different. So what if it just says factor this polynomial completely? You might see some directions like this in the future. So the first thing you want to do is look for a GCF. I'm going to write that over here. Look for a GCF, or a greatest common factor. So with all these 3 terms, I know that 3 is a factor of all of those numbers. And that's going to be the greatest common factor, right? Because this term doesn't have any greater factors. I can also see that all of these have an x with them. I can factor out an x as well. So the GCF of each of these 3 terms is 3x. So let's undistribute the 3x. Let's factor that out. And so we got to think about, well, what's left? So 3x times what is 3x to the third power? So that would be x to the second power, right? And again, I could write a 1 here. 3x times what is 30x squared? And that would be 10x. And 3x times what is 63x? That would be 21, right? 3x times 21 is 63x. Okay, remember our directions had factor this polynomial completely. So now that we're here, let's ask ourselves, can we factor this anymore? Can we factor more? And maybe you are noticing that in class, we have factored things that look like this. We can continue factoring this polynomial. And so to factor this part that's in the parentheses, we need factors of 21 that add to 10. So if we list out our factors of 21, 1 and 21, 3 and 7. Oh, well, 3 and 7, those add to 10, right? So I could rewrite this polynomial, the part that's inside the parentheses, into its two factors, x plus 3 and x plus 7. And then don't forget, there was still this 3x here, right? So that's still part of this factored polynomial. And so now we have finished. We have factored this polynomial completely. And so this third degree polynomial that we started with is equivalent to this factored form here.